السلام عليكم ورحمة الله وبركاته. In the name of Allah, the most gracious, the most merciful. Now, inshallah, Rabbil Alameen, we will talk about chapter 14, section 2, thin lenses. As we see in front of us, we have the main of the two types of lenses that we will study in this section in some cartoon figure. Okay, but this will be helpful to understand some points about these lenses. First of all, let's remember what's meant by lens. Lens is a transparent object that refracts light rays such that they converge or diverge to create an image. And let's remember that we said if they converge, the rays themselves will meet together or will intersect together to give what? To give the image. So the image will be real. If they diverge, the rays cannot or can never meet each other because they are going far from each other. Okay, so will an image be formed here? Yes, but by what? By the extensions. Excellent, by the extensions. Okay, and whenever the image is formed by the extension, it's called virtual image. Okay, well, to create an image. Well, so here it's a transparent medium or transparent object. This is the lens. Okay, to differentiate between the two types of lenses, let's imagine this figure. Okay, here before everything we have to look at this. We will consider that the lens as a transparent medium, like I'm drawing now. This is not the lens, but the lens is the transparent medium that's bounded by the interference of two spheres. If you imagine that we have two spheres, these two spheres are overlapping now. Okay, so here this part, if it's a transparent medium like glass, like plastic, it's called a lens. But because this is the lens, but the dashed lines here with the orange, okay, are imaginary. Okay, this is the lens. This is the lens. Well, so this is the lens. This is the lens. The shaded part. The shaded part. Well, the two faces of the lens are convex, so it's called convex lens. This face has a focus in front of it here, center of curvature, sorry, and another one, that one to right, has another center of curvature here. So here we have two centers of curvature. The line that joins two centers of curvature here will be the principal axis. I hope it's clear. Well, otherwise, if we consider that we have two spheres like this, if we bring this sphere here, okay, in this case, the region between the two spheres will represent, this is the region. It represents what? It represents this. The lens which is concave lens. Okay, so it has two faces also. This face to right, it has center of curvature here, and this is face to left, it has the center of curvature here. Okay, and the line between them is the principal axis. Okay, so we had an overview on the nature of the lenses. Well, the convex lens is converging, lens. So here the convex lens is converging. So if the light rays are falling on it, they will meet each other in that point that we will call a focus. But this is the right focus. We will have another focus on the left-hand side, okay? So we have two foci here because we have two faces, okay? So we have two centers of curvature, we have two foci, and so on. But here, if the rays are incidents parallel to each other and parallel to the principal axis, they will diverge. Well, okay. What about the focus here? The focus here will be along the extensions of these divergent rays. Okay, so here we have, this is the focus, capital F, because small f stands for the focal distance. Okay, so here we said the converging, which is the concave, which is diverging lens, has a virtual f. So its focal distance will be negative. Its focal distance will be negative. So sometimes, by the way, the concave lens or the diverging lens are called negative lenses because the focal distance are negative. And the convex lens has a real focus, so its focal distance is positive, and it's called a positive lens. Well, this diagram shows us the behavior of the rays in the two types of lenses. This is a diverging lens, okay? And the diverging lenses are concave. Mr. When we are talking about the mirror, you said the concave is converging. Yes, in mirrors, the concave is converging, but in lenses, the concave is diverging lens. Okay, it's very important. Okay, in mirrors, the convex is diverging, but in lens, the opposite. The convex is converging. Okay, okay. Well, so converging lens, which is convex lens, it's the corresponding lens to the converging mirror, which is the concave. Okay, because they have the same image cases and approximately the same behavior of the rays. Okay, but the diverging lens is corresponding to, which is concave lens, it's corresponding to what? The convex mirror, the convex mirror. Okay, the lenses, like mirrors, have focal points, as we said, but two focal points for each lens, not one. For example, if I sketch, this is, which is converging mirror, okay, I'll make what? I'll make a principal axis like this, and I'll put a focal point here and another focal point here. This is F. Here I have F, 2F, F, 2F, because I have two faces here, this face and this face. Okay, well, if you are talking about the diverging, we will make the same. This is the diverging mirror. I'll make the principal axis in the middle, as I'll explain a few seconds later, inshallah. Okay, focal point here, focal point here. This is the center of curvature, and this is the center of curvature. Okay, so these are the main points, as we will explain, inshallah, of the lenses. Well, lenses have optical center instead of mirror pole. If you remember that in the mirror, we talked about the point that's located in the center of the mirror face. And we call this point as the pole, the mirror's pole. But here, we have, instead of the mirror pole, we have another important point, which is called the optical center. This point is called the optical center. It's the point of the lens. Well, that leads us to talk about the main terms of the lens. Okay, first of all, as we agree together to do in mirrors, we will agree together when we want to draw any case or any ray diagram of the lens. We will do the following. Number one, we will make a horizontal line like this, and we will put a vertical dashed line like this. It should be so light. It should be so light. Welcome, Muhammad. Should be so light. Okay, so now we take our first step to sketch the ray diagram of the lens. Okay, so number one, we sketched a horizontal line like this. Then we will make with a very light pencil, we will make a vertical line that will represent the lens. Okay, then if we want to make it convex, we will make like this. Okay, then we will put our points. We will put 5 points here. Number one, this midpoint is the center of the optical center. So this is the optical center. Here, this is the optical center. Here, this is the first focal point, and this is the second focal point. The distance from here to here should be the same. Here and here, the center of curvature of both faces. This focus and this center are of this face of the lens. This focus and this center are of this face of the lens. Okay, so this is the optical center. This is F1, and this is 2F1. This is F2, and this is 2F2. And instead of writing F1 and F2, because here we are talking about a simple kind of lenses, we will say F, F2, F2F. These are the main points. Okay, where is the principal axis? This is the principal axis. This is the principal axis. Okay, if we want to make a convex lens, we will make the same. Number one, we will draw a line Okay, Muhammad, I'll tell you, but I'm recording the period now. And inshallah, I mean, anyone who is absent, inshallah, can see the video. Okay. So now, this is the principal axis. I know that you may have
بس قطش الصوت ما سمعتك شوي.
نعم. طيب اوكي يا محمد، انا عارف انت تقريبا عندكم حصه بعد دي. اوكي مفيش مشكله. I understand because I sent the link to the mindset instead of sending it to the 10 set. Okay, that makes the difference. That made the difference. Okay, I told you in the group. Then, so this is number one. We will make the principal axis. We will put a point here, another one here, third one here. They should be evenly distributed like this. Okay, we will make this dashed line. Then we will sketch our lens. This is the optical center. This is 2F, F, F, 2F, and this line is the principal axis. At this point is the optical center. Well, the reference rays of the lens. We have three cases of the lens, like the three cases of the mirror. The first one is this one. If the ray is parallel to the principal axis, this is the principal axis. Okay, if the ray is parallel to the principal axis, this is F, and this is F, and this is the optical center. Okay, parallel to the principal axis, it bends through the focal point. If it's going through the focal the optical center, it will go straight, like the green one here. Okay, this ray 2. This is the optical center, so it will go straight. In the third case, if it's the incident ray is passing through the focal point, it will bend parallel to the principal axis. They are the same, approximately similar to the cases of the mirrors, except for the one that's passing through the optical center. Okay, whenever they meet each other, the image will be formed as we see. So here the image is inverted, as we explained in mirrors. Well, let's see the ray diagram of the diverging. Okay, here the first ray parallel to the principal axis. You see the principal axis parallel to the principal axis, so it moves away such that its extension passes through the center of curvature. Okay, this point is important to be understood. Okay, to understand that, I'll explain. I'll sketch it here. Okay, now what we will do to sketch a diverging lens, we'll make like this. We will make like this. This is the principal axis, and we will sketch the principal axis. Okay, we will put this is the optical center, the focus, 2F, F, 2F. So here, this is F, 2F, F, 2F. Okay, well, okay, Muhammad, okay. Okay, you know that you have here the key. Thank you. I know. Thank you very much. Here, these are evenly distributed points. Okay, then we will make the diverging lens as you see. What are the points here? This is a very important point. What are the, sorry, let's sketch the rays. If the rays incident parallel to the principal axis, it will not move if through the focal point because it's diverging. So this will be a mistake. It will diverge, but diverge such that the ray extension through the focus, as I'm drawing. So it will diverge in this direction. So it will diverge in this direction. Okay, this is the incident. This is the refracted. Okay, so such that the extension of it passes through the focus. The two rays, the other rays, let's make one with yellow. If one is falling through the optical center, it will go straight. Okay, if one, it will go straight. Yes. Okay. Let's see these cases. Oh, the third case, if the the third case, if the incident ray is falling such that its extension along the focus, it will go parallel to the principal axis. Well, so they are the ray diagrams. If the incident ray, this is the incident ray, okay? If it's parallel to the principal axis, it will pass through the focal point if the lens is converging, or directed away from the focal point, and it will direct it such that its extension passes at the focal point, okay, as we explained. Okay, central ray, central ray, means the ray that's passing through the the optical center, it will go straight in both cases. Okay, a focal ray, which is passing through the focus, here it will go parallel to the principal axis, and in the diverging lens, it will go parallel to the principal axis. Well, now let's talk about the characteristics of the lenses images. The converging lens, like the converging mirror, like the converging mirror, like converging mirrors. They have all the cases of the converging mirrors. Okay, so the converging lenses can produce a real or virtual image of real objects, as we explained in the mirrors. Okay, they may be magnified, equal, or diminished. Okay, the diverging lens can produce only virtual diminished images of real objects. Only one case of diverging mirror, as we said when we were explaining the diverging lens, looks like the diverging mirror even in its cases, like diverging mirror. Well, here let's make it clear. This is a conversion. So this is the ray diagrams of the converging. If the object is here, if the object is too far, the object is at infinity, it's too far, okay, what will happen? The rays, those are coming from the too far objects like stars, like the sun, like the moon, and so on. They will meet each other at the focal point. So the image will be a point image at F. Okay, the application burning a hole with a magnifying glass. Okay, well, the second case, if the object is outside 2F, here this is the object. We want to get the diagram as we were making in the mirrors. Parallel 3 rays. One is parallel to the principal axis. It will go through the focus. The second ray is parallel to the is passing through the central, the optical center. It will go straight. Okay. The third one is going through the focal point. It will refract parallel to the principal axis. So the image will be formed here. Here the image is smaller or diminished. Okay, it's real, inverted, and between F and 2F. These are the characteristics of the image. Okay, I think so easy. Okay, so the image is here, it's real, and because it's real, I have to say it's inverted or upside down, inverted, okay, and it's diminished or smaller than the object, and it's between F and 2F. So 1, 2, 3, 4 characteristics of this image. This is if the object is outside the 2F. Okay, well, so this case can be explained quickly as the following. Number one, we will make what? We will make this line. F to F, F to F. We will put the object here. The first line goes through the focus. The second line go straight, so they will meet each other here to form the image here. Okay, I hope it's clear. Okay, Mr. Can we use only two rays? Yes, we can use only two rays. Okay, well, the next case, if the object is at 2F, or here, the object is at 2F, parallel, go through the focus. Central, go straight. Through the focus, go parallel. So, or goes parallel. Okay, they will meet each other at 2F. So this is equal. This is real, inverted or upside down. Okay, it's real, inverted, equal in size, at 2F. Well, the next case, between F and 2F, by the same way, we will get the image here, and these are the characteristics of image. Okay, if the object is at F, the image will be at infinity, so it will be a spot light. Okay, finally, this is a very important case, because this case represents what? Represents the magnifying lens of the simple microscope, Well, here, this is the object. It's inside F. This is the object. The three rays, sorry, this is the object. I'm so sorry. Sorry. This is the object. Inside F, the object. It's written object. The three rays here will be difficult to be sketched, so we will sketch two. Number one, in the figure, the three are sketched, but when we are drawing it in the exam or anywhere, okay, we will make two only. This is parallel to the principal axis, so it will go the focus. This is go through the optical center. The two are enough. Okay, don't sketch this because it will make large amount of interference with you. Okay, what will happen? They are going far from each other, so you will extend them like this, such that their extensions, the dashed line, will meet each other here where the image is formed. So the image here is formed by the extensions, so it's virtual. This is the first virtual image. And virtual means upright. It's not upside down, it's upright. Okay, this is number one. It's magnified. And it's magnified. Okay, and it's at the same side as the image. Is it the real, or is it the normal image? Is it the normal position of the image to be with the object? No. So here, Q, which is the distance of the image, will be negative. the distance of the image will be negative because it's with the object. Okay, and this is not the real or the normal position of the Q. Remember, Q is the distance of the image. So the image here, the distance of the image will be negative. Why? Because it's with the object. It's with the object. In lenses, this is not the normal position of the image.